Hi friends, welcome back to another session of BGP. My name is Sandeep and today we are going to cover BGP attributes. BGP attributes are basically of two types. So before we understand that, let's understand why do we require a BGP attribute first. Okay, so let's say we have a router. Okay, let's say we have a router here and um, we have one more router. There we go. Let's say we have three routers and this is connected here this way, and there's one more link connected here, and we have got a network. Let's say I have 200 network at the service provider, and I'm receiving this 200 network from link A as well as from link B or ISP B. So in my BGP routing table or my routing table, there are two paths available to reach the network 200. So which way I should prefer, or when someone sitting here and I want to send a traffic to this 200 network, which path it is going to take. So we have some metrics here which defines how the traffic should be sent from this router, and those that metric in BGP protocol is called as attributes. These metrics are different in other routing protocols. For example, OSPF has cost, EIGRP has different metrics, and so on. So today we are going to discuss BGP metrics. We call it as BGP attributes. So basically, there are two types of BGP attributes. One is well-known, and second one is optional. So let's understand. There are two types of BGP attributes. One is well-known, and the other one is optional. So let's understand what are these well-known attributes. So in the well-known attributes, we have got two types. One is mandatory and the other one is discretionary. So we have mandatory well-known attribute and we have discretionary well-known attribute. So let's cover this part first, and then we will get on to the optional attributes. So far I believe you have understood there are two types of attributes, well-known and optional. In the well-known, we have again two categories. One is well-known mandatory attributes and well-known discretionary attributes. So well-known attributes are the attributes which must be understood by all BGP neighbors, and they should exist on BGP update messages. So for example, the mandatory attributes. Let's say I'm running some mandatory attributes between these three routers. All these three routers should understand that attribute. All these three routers should understand this attribute. And also, whenever there is a packet sent between the three routers, they should send this attribute in that packet. So there are basically four types of packets in BGP, in which one type is update. So um, when you form a BGP neighbor, when the first time BGP neighbor comes up, it forms three-way handshake. So TCP SYN packet will be sent, TCP SYN ACK packet will be sent, and then ACK packet will be sent. This is your basic TCP three-way handshake. So once this TCP handshake is done, or three-way handshake is done, and once the TCP session is established between router 1 and router 2, there are certain BGP messages sent. So first message is BGP open message, then there is a BGP keep alive message, then there is a BGP update message, and there is a notification message. The third type of message, which is BGP update message, is basically used to carry these attributes. So this BGP update message, which is exchanged between two routers, carries all our attributes. Okay, so in this attribute, um, you know, um, so these BGP update messages, which are sent between these two routers, should understand these attributes, which is mandatory attribute, and they should always carry this in those packets. Okay, so these type of attributes are called as mandatory attributes. Okay, so you can understand that these mandatory attributes must be understood by all BGP neighbors. So they should understand by all BGP neighbors, and they should exist on a BGP update message. Okay, so for an example, let's say these three routers. Okay, let's carry out with a discretionary attributes. So the discretionary attribute must be understood by all BGP neighbors, but they don't have to exist in BGP update messages. So which means that this kind of attribute or mandatory, well-known discretionary attribute should be understood by all BGP neighbors. They should understand, but they don't have to carry this. Um, but they don't have to carry this attribute in the BGP updates. Okay, so we have got these three attributes as a mandatory, and these two attributes as a discretionary attributes. So whenever a BGP neighborship is formed, you could always see that origin, AS path, and next hop attribute is always carried. So these are the mandatory attributes. Discretionary attributes, you could see local preference and atomic aggregator. Okay, so before we move on to the optional attributes, let's understand where this update packet which I was talking about, and where these attributes fit in. Okay, so I have got some packet captures. Let's open one of the packet capture. Let's say for an instance, let's say I had performed a IBGP neighbor session. So let me just open an IBGP session. So which I was talking about was this one. I was talking about this. So let me take a screenshot again. Let me open a MS Paint, and I will explain you what are these captures. So I have two routers, and I am forming IBGP neighbor between these two routers. Okay, so you could see that when we started, let's say this is my 4.4.4.4, and this is my 3.3.3.3. Okay, and the BGP, you could see that 4.4 is the source which has initiated a SYN packet. BGP runs on port number 179. So this has started a session. It sent a SYN packet. Okay, and second router, that is 3.3.3. Let's consider this as router 2. This is router 1. Router 2 has sent a SYN plus ACK. So this is SYN ACK packet. You could see that the source port number is 179 and destination is the same which was originated. So SYN ACK, and then you could see R1 has sent the acknowledge packet. So this has completed three-way handshake. Okay, then once the three-way handshake is done, BGP has sent an open message. BGP sent an open message. So this is three-way handshake is completed here. A TCP session is formed. Now BGP sent an open message. In the return, R2 has sent open plus keep alive, and then router 1 has sent keep alive message. So we will discuss these all messages in another video, but I just wanted to show you where those BGP attributes come in a picture. So let me, once the keep alive message is started flowing between the two routers, let's open message. Then we see this has sent open plus keep alive, and then router 1 has sent a keep alive message. So once the router 1 has sent a keep alive message, router 2 has sent an update. Router 2 has sent an update message, and all the attributes are carried in the update message. So once router 2 has sent an update message, you could also see that router 1 will also send an update message. So you see that here router 3 or router 2 has sent an update message here. At the same time, once this update message is received, the next router has also sent an update message. So let's see where these attributes are. Okay, so let me show you how the packet looks like. So this is our frame. We have Ethernet header, which contains MAC addresses. Then we have IP header, which contains your IP addresses. We have TCP header, which shows um, your source port and destination port number. On top of this, we have BGP update messages. So I have clicked on this update message, so we could take a look on the update messages. So if you go down here, you could see a field called path attributes. Okay, so in this BGP update packet, you could see a path attribute. In the path attribute, you could see that there are various attributes. So I could see that there are 5 attributes sent from router 2 to router 1. First one I see origin, then I see AS path, and then next hop. So these three attributes are well-known mandatory attributes. You see any you could capture any packet on any router, and when you are running BGP, you will definitely see these three attributes. So these are the mandatory attributes, well-known attributes. Mandatory, these are well-known mandatory attributes. Okay, so you could see that origin, AS path, and next hop. Let me open the capture again. Origin, AS path, and next hop. These are the mandatory attributes. Okay, if you explore this, you could see that this is well known. Transitive means it it can carry to the next router. Okay, so it is not going to show here as mandatory, but you should understand when it is showing well known, it is well known mandatory attribute. If it is well known discretionary attribute, it will show as non-transitive here. Okay, so this is well-known transitive, which means that this is well-known mandatory attribute, well-known transitive, which means that this is well-known mandatory attribute, and there's again well-known mandatory attribute. Okay, so these three are well-known mandatory attributes. Let me minimize this. So I'll repeat it again. Basically, there are two types of attributes: well-known attribute and optional attribute. In the well-known attribute, we have two categories: mandatory and discretionary. Mandatory is the one which needs to be understood by all the BGP neighbors. This one should understand, this one should understand, and the third router should understand. And also, it should carry in every update packet. Whenever it is sending any BGP update packet, it should have these three attributes. So these are always carried: origin, AS path, and next hop. Why these are carried, we will discuss in a separate video. So the discretionary attribute must understood by all BGP neighbors, but they don't have to exist in the BGP update message, which means that they should understand, but it is not mandatory that they should carry this attribute. So local preference and atomic aggregator, it is not necessary that it should carry in the BGP updates. So let's see our iBGP. Here I see local preference and multi-exit discriminator. So this is taken from the iBGP. So we had set up local preference on our neighbor. That's the reason it is carrying here. So I'll take a look at one more capture from BGP. This is the um, BGP capture from between the two routers, and it is eBGP neighbor. The one we saw was iBGP neighbor. So you could take a look at update packet here. In the update packet, as we discussed, the three mandatory attributes are already there: origin, AS path, and next hop. But you see that local preference is not here. which means that local preference is discretionary attribute. It doesn't have to be carried in all BGP updates. When we configure something on a router to carry it along with updates, then it is going to carry these attributes. Let's say you have configured local preference on this router, then it is going to carry, but it is not mandatory that it should always have on the BGP updates. So these are the two discretionary attributes: local preference and atomic aggregator. Let's see how it looks on the Wireshark when we configured local preference. So in the iBGP neighbor, I had configured local preference. So you could take a look at local preference. It is shown as well known. This is well known attribute and this is transitive attribute, right? So this is well known transitive attribute, or you could say that this is this is discretionary attribute, which doesn't have to be carried on the update package. I hope these two attributes are clear, mandatory and discretionary. Then on the optional attribute, okay, so well-known and optional. On the optional attribute, we have two types. One is transitive and one is non-transitive. One is transitive and non-transitive. So transitive is nothing but the same example. Let's say we have three routers. It doesn't have to understand by all BGP implementation, which means that uh, it is not mandatory or it is not required to understand this BGP attribute. But since the transitive flag is set, they will be passed to other neighbors, aggregate and community. Okay, so there's one more called non-transitive attribute. Non-transitive will not be passed to other neighbors, so they don't have to be understood and they don't have to be carried in the BGP updates. So to give an example, I see that it's a bit difficult to understand. So let me give a simple example here, which is not related to the routers or anything. So let me take a new example. Let's understand well-known, mandatory, and discretionary. So let's say we have a classroom and we have two students sitting in a classroom. Okay, so in this classroom, let's say they are exchanging some notebooks or notes. They are exchanging some notes. Okay, so this guy sitting here is with the name A and this guy is with name B. Okay, the mandatory attribute we could compare it as they should know a language to communicate between each other. So let's say they know English. Okay, so both of these should communicate via English. They should understand this language and they should also write a notes in English. This is nothing but your mandatory attribute. You could see that all BGP neighbors, they must understand this particular attribute and they should exist on BGP updates. You could tell that English language is what they should understand, and when they communicate with each other they should carry the English language in their notes. This you could compare it with mandatory, well-known mandatory attribute. The second example is discretionary. So in discretionary attribute, the same example, the same example, but there is a short modification, a small modification. So A and B is in a classroom. They should understand English language, but there is no need to send any notes between these two. It is not mandatory that they should exchange the notes because they don't know how to write the English, but they speak and they understand English. This you could compare it with the dictionary. This you could compare it with a discretionary attribute. Okay, so I hope this is clear. Then the next attribute we discussed was optional. In the optional, there is something called transitive. So in the transitive, they don't need to understood by all BGP implementation. but since it's a transitive flag is set, they will be passed to other neighbors. So the same example, two two people sitting in a classroom, okay, they don't have to understand this English language, but when they pass some information, when they send some notes between each other, they'll write something, right? And it has to be English. This you could compare it with transitive. Okay, so they don't have to understand this language. They don't have to be implemented by they don't need to be understood by all BGP implementation. But since it's a transitive flag is set, they will be passed to other neighbors. Whatever he writes here, he will pass to this guy. Okay, similarly non-transitive. Um, in a non-transitive, they don't need to understand the language, and also when they send these packets to the next neighbor, they don't have to send any packets also to the next neighbor, will not be passed to other neighbors. So this is your non-transitive attribute. So the transitive attributes are aggregator and community. The non-transitive attributes are MED, originator ID, and cluster ID. The most important attributes I have seen are these mandatory origin, AS path, next hop, and also the most widely used attributes are local preference and MED. Okay, so um, these are the types of attributes. When you take the order of operation, which one would be preferred? Let's say on this router I have configured wait as well as local preference. So let's say this 200 network is reached on this network on this router, and now I have two paths, one via this and one via this secondary, this one via the ISP A and one via the ISP B. In this case, which one I should prefer? So to get the preference, we need to configure these attributes. So let's say I have configured wait attribute as well as local preference attribute. So which one would be preferred? It will always prefer wait attribute because wait is at a top level. Okay, so similarly, the first attribute will be preferred as wait, second will be local preference, then locally originated, AS path, origin type, then MED, EBGP or IBGP, and so on. This video was created just for a basic understanding of BGP attributes. I will create different videos for all these attributes, and we will understand each attribute in detail with Wireshark captures and how to configure each of these attributes and how to do those in real time scenarios. So I hope this is been understood to you, and if you like this video, click on like button, and I would like to thank you for watching. If you haven't subscribed my channel, please subscribe so I'll get more videos for you. Thanks a lot. Have a good day.